Very good morning. We are discussing Kolar District Science series first science question paper key answers. We already discussed physics. Now we are going to discuss part B, that's a chemistry. Then first three questions are multiple choice questions. First one, 14th. Correct a decreasing order of reactivity of metals. Decreasing order of reactivity of metals. This is also exact they took from model question papers. Magnesium high reactivity compared to magnesium, aluminum low reactivity compared to aluminum, zinc has a low reactivity, and compared to zinc, iron very less reactive element out of these. Okay, not all others, out of these. Then question number 15, the acid used to prepare a preservative for pickle is acetic acid. Which one? Acetic acid. Then 16th one question, oxygen gas liberates on a thermal decomposition of a compound X. The compound X forms a precipitate on reaction with potassium iodide. The color and molecular formula of precipitate formed respectively are. Okay, that's yellow lead iodide. Yellow lead iodide. Option B, right answer. Then answer the following questions, each carrying 1 mark, total 3 marks. 17th one. What is an exothermic reaction? The chemical reaction in which heat is released or liberated along with the products in a reaction is called exothermic reaction. Then 18th one. Write a structure of benzene. Okay, molecular formula of benzene C6H12. Then 6 carbon atoms. How many? 6 carbon atoms are arranged in a hexagonal shape, and for each carbon atom, what? For each carbon atom we arranged very sorry for each carbon atom here 6 what 12 I wrote C6H benzene formula. For each carbon atom we arrange one hydrogen atom, we arrange what one hydrogen atom, and alternatively wherever you want keep a double bond in between carbon. Okay, this is also benzene structure only, simple, very simple. Then 19th one. A student stores a plaster of Paris is often container, open container. What is this method correct? Justify your answer. No, this is because plaster of Paris reacts with atmospheric moisture and converts it into gypsum, or reacts with the moisture and hardens. That's why, okay, keeping an open container, it's not suitable for plaster of Paris. Then answer the following questions. It's a 2 mark questions. Total 3 questions are there. 3 2s are 6 marks. Okay, 20th one. It's a diagram. Draw a diagram showing a reaction with zinc fragments with dilute sulfuric acid and liberation of a hydrogen gas. That hydrogen gas comes in contact with a matchstick fire. It makes a pop sound, or it gives a bright light. Okay, here zinc pellets are there, and this is the delivery tube. This is the container having a soap water. Okay, then this is definite question. Out of 2 diagrams, this is one fix. This one or another one. Okay, that's also what a reaction of a metal with and what liberation of a hydrogen gas only. Then question number 21. Briefly explain the steps involved in extraction of mercury from cinnabar. When cinnabar is heated in air, it is converted into mercuric oxide. Mercuric oxide or mercury oxide, HgO. Cinnabar, HGS reacts with the environmental reacts with the oxygen, that's air. Okay, what it gives? It gives a mercuric oxide with liberation of a sulfur dioxide, and whatever here mercuric oxide is there, again it reacts with a, when the mercury oxide further reacted with reduced to mercury. Okay, again it reacts with oxygen and it reduces what mercury and it liberate environment oxygen. Question number 22. Draw the experimental setup of electrolytic refining of copper and label anode. Label anode. Okay, whatever the mud is settled down, that's a anode mud. And what here? This is the what? What they asked? Anode mud only they asked. This is the what? Anode, and this is the cathode. Positive. Oh, sorry, very sorry. Reverse I shown. Negative wherever the positive terminal is there, Here positive terminal is there, that's why it's a anode. Okay, and this is the negative terminal this side. Okay, that's why it's a cathode. This is the tank, this is the copper sulfate solution. Okay, they are interconnected with the help of wires. Then answer the following questions. These are 3-mark questions. Total 3 questions are there. 3 3s are 9 marks. 23rd one. Complete and balance the following equations. Okay, glucose C6H12O6 reacts with oxygen. It's a respiration reaction. It gives a carbon dioxide, water, and energy. Okay, then to balance a carbon, what we have to done here, 6 carbon atoms are there. That's why we took here 6. Okay, then 6 2s are 12 oxygens. To balance a hydrogen, here 12 hydrogens are there. That's why to balance a hydrogen, here we took a 6. That's why 6 2s are 12. Now to balance oxygen, here 6 2s are 12 oxygens are there, and here 6 1s are 6. Total 18 oxygens are there. To balance those 18 oxygens, what we done, we took here 6. 6 2s are 12, here 6. Okay, here also 18, that side also 18. That's why LHS is equal to RHS. Very simple way. Then sodium sulfate reacts with a barium chloride. It gives a barium sulfate and sodium chloride. Here chlorine atoms are 2. Here chlorine atom 1. That's why to balance this one, what we done? We done here, but we took here 2. Okay. Then here Na2. That's also balanced. And Ba single, SO4 single, CSO4 single. Then MnO2. Manganese oxide reacts with the hydrochloric acid. What it gives? Manganese chloride, water, and chlorine. To balance a hydrogen, here not only hydrogen, to balance a chlorine. Okay, here 1 chlorine is there, here 2 chlorines are there. To balance a chlorine, okay, here also 2 are there, here 2, here 2, total 4 required chlorine. That's why we took here number 4. Then whenever we took a number 4, then hydrogen also turned into 4. That's why we took here 2 H2O. Remaining all things are balanced. Oxygen 2, manganese 1, another manganese 1. Remaining all things are balanced. Then write the balanced. For this question only they asked another one R-type question. Write the balanced chemical equation for the following reaction: burning of a natural gas. Natural gas is nothing but methane. Methane reacts with oxygen. It gives carbon dioxide and water. Okay. Then to balance oxygen, here 2 oxygens are there. Here 1 oxygen is there. To balance oxygen, what we done? We took here 2. If we take 2 here 2 means what? 2 2s are 4. 4 oxygen occurs. Oxygen not balanced, because here 2, here 1, 3 are there. To balance here oxygen, this is, or here also we took a 2. Then what? 2 plus 2, 4 it turned. Then whenever we took here 2, here hydrogen turned into 4. Okay, here also hydrogen 4, carbon 1, carbon 1. Remaining all things are correct. Then second one, decomposition of silver bromide by light. Okay, decomposition of silver bromide by light. Silver bromide AgBr, it reacts with Ag and Br2. Okay, Br2, to balance this 2, we took here 2, and if we take here 2, silver also 2. That's why LHS is equal to RHS. Then next one, the iron nails is placed in a copper sulfate solution, CuSO4. Okay, then iron nail Fe, it reacts with iron and it gives a FeSO4, because iron is more reactive than copper and it displaces a copper. Okay, there is no need to balance this reaction, because here also copper 1, here also 1, here also sulfate, here also sulfate, iron. There is no need to balance this reaction. Okay, then keep as it is. Question number 24. Name the products of a chloralkali process. Write one use of each. Okay, the products of chloralkali process are sodium hydroxide, hydrogen, chlorine. Then uses: sodium hydroxide, removal of grease of metals, soaps and to prepare soaps and detergents, paper making industry, artificial yarns, we use a sodium hydroxide. Then hydrogen used as a fuel in rockets. To prepare artificial butter, we use a hydrogen. Ammonia fertilizers, whatever the ammonia fertilizers, urea, other things, to prepare those we use a hydrogen. Then chlorine used in the purification of water, okay, and it is also used to clean swimming pools and to prepare a polyvinyl chloride, PVC. Okay, it is used as a disinfectant. Okay, then to prepare a CFC, chlorofluorocarbon, lot of pesticides we use chlorine. Okay, then for this question they asked another one R type question. The pH values of a solutions A, B and C are 9, 5 and 7 respectively. Which solution has the highest concentration of hydroxyl ions? Which solution turns blue litmus paper into red? Which solution can be used to obtain the products of neutralization reaction? Which solution can be used as an antacid? Why? Okay, for here whatever the sub questions are there, those are all carrying half marks. Okay, the concentration of a hydroxyl ions is high in A because its pH is 9. Okay, out of those all 9, 5, 7, out of those which has a high pH, 9 only. That's why it's a base means it has more hydroxyl ions. The next one, changing a blue litmus paper into red, which one? B. Why B? Because its pH is 5. Whatever the substances, uh, they have a pH less than 7, they are all acids. That's why, okay, that whatever the acids are there, they changes blue litmus paper into red. That's why here answer B. To get products of the neutralization reaction, okay, what are going to react means A and B, because A is a base, that's a pH 9, and B is a acid, its pH is 5. That's why whenever they both reacts, neutralization reaction will occur. Use an antacid. Okay, we to prepare an antacid we use a B. We use a B. What slightly weak acid. Slightly weak acid. That's a pH 5. Okay, strong acids pH 1 or 2, 3, like this we use. But to prepare antacids we require what weak acid. So weak acid pH 5. The next one. This is because base is used as an antacid. Very sorry. What acid we not use? pH 5, 9. Whatever the pH has a 9. Okay, strong what a base. Our base we use to prepare antacids, because in our stomach acids are produced. To neutralize that acid we require a base. So here we use a base, that's pH. B pH is 9. I forgot. A pH is 5. Question number 25. Write any 3 examples for corrosion you observed in your daily life. Mention 3 preservative steps to overcome corrosion. Okay. Then write any 3 examples for corrosion of rusting of iron, green color coating on copper, black coating on silver. These are all examples for corrosion. Okay. Then mention 3 preservative steps to overcome corrosion. To measure or prevent condensation: painting, oiling, applying grease, galvanization, chromium coating, anodizing, okay, making alloys. These are all methods used to avoid corrosion. Okay, then next question made number, that's answer the following questions. It's a 4-mark question, single question is there. See then, 26th question. A. Write a equation for the conversion of ethanol into ethanoic acid. Draw the structure and dot structure of reactant of this reaction. So CH3CH2OH, alkaline KMnO4 plus heat, or antacid potassium dichromate K2Cr2O7 plus heat. What it gives? It gives ethanoic acid CH3COH. Then the structure of reactant, which one? CH3CH2OH, CH3CH2OH. Okay, that's a ethanol. That's a ethanol. Then ethanol, we can able to write which one? C2H5OH also, C2H5OH also, CH3OH also alcohol, but here we use C2H5OH. Then dot structure of C2H, C2H5OH. See there, for 2 carbon atoms, 5 hydrogen atoms are arranged, and in between carbon atoms single bond is there. And in oxygen forms a bonds in between carbon also and hydrogen also. So this is the dot structure of ethanol. Dot structure of ethanol. B. Briefly explain the cleaning process of soaps. Whatever the soap is there, it has two ends. One is ionic end, another one is a carbon end. So the ionic end of the soap reacts with the water, while the carbon end reacts with the dirt, that's a oil. Thus the soap molecules form structures called micelles. The hydrocarbon end of the soap molecule is towards the oil, and the ionic end of the end is facing towards the water. Then it causes emulsion in water. Thus the soapy micelles remove the dirt from the water and cleans the clothes. Okay, then part C, that's a bioscience. Okay, that's a bioscience. We discuss in our next clip. Hopefully these videos are helpful to score more. Try to share your friends and other groups. Thank you so much.